In a historic press conference, NASA reveals plans to build a permanent lunar city by the 2030s. The Artemis program aims to establish a sustainable human presence on the moon, with the first crewed landing since 1972. This initiative will serve as a stepping stone for future Mars missions, leveraging international partnerships and cutting-edge technology. The announcement sparks mixed reactions worldwide. While many celebrate the potential for scientific breakthroughs, others question the project's $93 billion estimated cost. Social media buzzes with debates, and protests erupt outside space agencies. Governments weigh funding commitments, highlighting the ethical and financial challenges of lunar colonization. NASA recruits top engineers, astronauts, and private companies like SpaceX and Blue Origin. Collaborations with ESA, JAXA, and CSA ensure global expertise. Astronauts undergo rigorous training in simulated lunar environments, while engineers develop habitats capable of withstanding extreme temperatures and radiation. Prototype moon bases are tested in Earth's harshest environments, like Antarctica and Arizona's deserts. These habitats feature inflatable structures, solar panels, and hydroponic gardens. Scientists simulate 14-day lunar nights, testing resilience against -280 degrees Fahrenheit temperatures and isolation stressors. The Space Launch System, SLS, rockets blast off, carrying prefabricated modules to the moon. Artemis 3, 2027, will land astronauts near the South Pole, where water ice deposits are critical for survival. Live broadcasts capture the fiery launch, with millions watching as humanity takes its next giant leap. Autonomous robots and 3D printers begin constructing the lunar base using regolith, moon dust. These machines, controlled from Earth, assemble habitats, solar farms, and radiation shields. NASA's unpack project tests printing landing pads, paving the way for larger structures. The inaugural crew arrives, entering the partially built base. They inspect airtight seals, test communication systems, and unpack supplies. The astronauts' first tasks include activating life support and collecting ice samples for water extraction, a milestone in sustainable off-world living. Living in low gravity poses unique challenges. Astronauts exercise 2 hours daily to prevent muscle atrophy and use recycled water systems. Communication delays with Earth require autonomous decision-making. Yet the crew finds wonder in Earthrises and groundbreaking research. A sudden solar storm forces the crew into emergency protocols. They retreat to radiation-shielded chambers as alarms blare. Backup systems kick in, proving the base's resilience. The event underscores the moon's dangers, but also humanity's ability to adapt. With the base operational, plans expand for lunar tourism, mining, and Mars missions. Companies like SpaceX book cargo flights, while families apply for future residency. The moon transforms from a scientific outpost to a thriving hub, ushering in a new era of interplanetary civilization.